Problem number 5. I'm thinking of a two-digit number. If the digits are reversed, the new number is 36 greater than my original number. If the tens digit of my original number is doubled and the units digit is halved, the new number is 17 greater than my original number. What is my original number? Alright, well, whenever I see digits problems, I want to write them, I want to do it by writing the number in expanded form. So let's say we have a number, we'll just call it AB, okay, where A is the tens digit and B is the units digit. Then I would write that as 10A plus B, okay, where A and B are just digits, okay. So that would be my hint to you, is to do it, to write these numbers that they describe up here in this form, and then you can solve it algebraically. So let's do that. So let's convert these statements into equations. So here we have a case where the digits are reversed and the new number is 36 greater than the original number. Okay, so if we reverse the digits, then we have BA, which would be 10B plus A. And the statement says that when we do that, we get a number that's 36 greater than the original number. So we had 10A plus B, but we know that this number is 36 more than that. So we can set up this equation like this, okay? And so let's go ahead and just simplify that. We could just subtract 10A from both sides and subtract B from both sides. Let's do that. Minus 10A and minus B. So minus 10A and minus B. So we end up with a negative 9A plus 9B is equal to 36. Okay, so that's a little bit simpler. Alright, now let's look at the second statement. If the tens digit is doubled and the units digit is halved, we get a new number that's 17 greater than the original number. So let's take the units digit and we want to double it. So we can actually write that as say 2A, right, times 10 plus half of the units digit, right? So that's B over 2, and that is equal to 10A plus B plus 17. Okay? Alright, so let's simplify that. So here we have 20A. Let's just again subtract 10A and minus B. And then we want to subtract 10A and subtract B here. So we'll end up with 20A minus 10A, so we get 10A. And if we take 1/2 minus 1, we get a minus 1/2 B is equal to 17. Okay? So now we have two equations and two unknowns. So let's see if we can solve those. Let's scroll down here just a hair. Alright. Well, I guess I'd like to eliminate one of these variables so I can solve for one or the other. And I can see that if I multiply this bottom one by 18, then this will become a negative 9b, and I can add these two equations together and get rid of the b. So I'm going to do that. So if I multiply that bottom equation by 18, I get 180a minus 9b, right, is equal to 17 times 18. So let's see, 18, 17, let's see, that's 56, 7, that's 1, 2, and 18, right? If I add those together, I get 306. Okay, so that's equal to 306. Okay, and now I'm just going to rewrite the top equation underneath it. I'll just put it underneath it. Okay, so that is a negative 9a plus 9b is equal to 36. And if I take those two equations and add them together, then the negative 9b and the positive 9b will just be 0. So 180 minus 9 is 171a, and this becomes 0. And so then this is equal to, let's add these together, and I get 342. Well, that's good because I really want these digits to be digits, so they have to be, some whole number. So if I divide both sides by 171, then I get a is equal to 2. Alright, well, we're halfway there. Now I just got to find b. So I'm just going to take that a equals 2, and I'll just substitute it into, we'll just do the top equation. So we have negative 9 times 2, because a is 2, plus 9b is equal to 36. So I'm seeing a negative 18. So if I add 18 to both sides, then I get 9b is equal to 54. That's supposed to be 9. And then if I divide by 9, then I get b is equal to 6, right? So we have a, we have b, so the original number had to be 26, right? And you could check that too. Let's see if that works out. So if we were to reverse the digits, we'd have 62, and if we subtract 26 from that, we should get 36, right? Because the new number was supposed to be 36 greater than the original number, so you can see if I subtract those two, that's true. I'll get 36. And if I double the tens digit and have the units digit, and I subtract 26, I should get something that's 17 greater than the original number. And you can see if I subtract 26 from 43, I do get 17. So it checks out too. So it's always a good idea to check your answer if you can. So the answer is 26.